Hello, everyone, and welcome to another Code Remix Weekly. I'm your usual host, Sam, without our other usual host, Tim, as Tim could not help but decide that skiing was more fun, snowboarding was more fun than being here with all of you. He's obviously wrong about that. Live streaming is way more fun than going up on an idyllic mountain and challenging your body and mind to traverse it with only a flimsy board strapped to your feet. Obviously, that is a ridiculous waste of everyone's time, and I'm not jealous at all. So anyway, let's get right into it this week. Not too many announcements to start with. We do have a new release of Open Rewrite that went out yesterday with a bunch of bug fixes. Notice a couple around JSON path. Had a couple issues with YAML recipes being a little bit over eager to match things when they're JSON paths that they shouldn't have. So if you're seeing any unexpected results there, be sure you have upgraded to the latest Open Rewrite. I don't have a full event calendar in front of me, but I know that the next major thing kind of coming up for us is Dev Nexus, March 4th to 5th in Atlanta, Georgia, where we will be speaking. It'll be a great opportunity to meet some modern folks. I think Justine is going to give a great presentation. I think Jonathan is also going to be there. Yeah, Jonathan's going to be there, Modern founder and CEO. I think Olga's also going to be there, other Modern founder, although she's not listed as a speaker. So anyway, you'll get to meet some cool Modern people if you go to Dev Nexus. And if you don't go to Dev Nexus, or even if you do, you should definitely join us at the Code Remix Summit in Miami, Florida. And if you are, I believe we do have a discount code for that. But yeah, if you are, it's going to be a good time, May 12th through May 14th. We're having some more signups come in, but there are still spots available. So I look forward to seeing all of you there. Let's see. And then, let's see. Oh, here we go. Yep, Dev Nexus is coming up. And then, oh yeah, if you're not going to be able to see Justine at Dev Nexus or at the Code Remix, then, or maybe you prefer Montreal to Miami, Justine will be presenting at Confu in their Montreal 2025 session. So when is this coming up? This is coming up soon, February 28th. So so that's 2 days from now. So if you wanted to see Justine there, you're probably already booked for it, or you're too late. All right, so let's get into our recipe authoring tips for the day. It's been a little while since we had some recipe authoring tips on the stream, and our viewership is a bit wider now. So I think it's time to give the recipe authors out there some useful tips and techniques that might not be immediately obvious to you from the documentation. And so, kind of to start with, like tip number one is about, maybe this is a combo tip, or maybe this is tip 1 and 2 together. But so let's take so tip number 1 is what to do when you don't have JavaTemplate available. Maybe you're operating in a language like Groovy or Kotlin or C# or something, where we might not have a JavaTemplate equivalent ready to go, but you have a recipe and you need to update some LST elements in it. And constructing them by hand is miserable. You don't want to hand construct LST elements. So, how do you go about that? And this upgrade transitive dependency version recipe in the in Rewrite Gradle provides a great example of this, because we don't have a Groovy template, equivalent to JavaTemplate. So what do you do when you have a recipe that needs to generate LST elements, such as to produce this constraint block without JavaTemplate? And this recipe has an answer for you, and that is to new up a Groovy parser. And then, if it's a Groovy LST element you want, or a Gradle LST element you want, to new up the parser and to directly parse the snippet for an entire valid source file, right? Some of the main work that JavaTemplate does for you is you provide just the snippet you want, then it builds a valid source file around it, parses it, then traverses in and retrieves the LST element just corresponding to your snippet. So if you don't have all those utilities available, you kind of have to do it yourself. So for example, in this case, what we're wanting to generate here is just this like constraints invocation, but we have to wrap it in a full valid, in this case, Gradle kind of script, and parse that into a g.compilation unit with the Gradle parser, and then we go and manually fish out of the resulting compilation unit just the piece that we're interested in. Now, so that's tip number one. Like this is how you do it. And then the question is, how do you do it efficiently, right? Because it's particularly with the Gradle parser is noticeably kind of slower than some of the other parsers, or certainly slower than like the Java parser or like the YAML parser or something like that. And so if you were creating these LST elements really frequently, you would make your recipe slower than it needs to be. And so, in this recipe, what I have done, and I'm actually going to change this while we're live here, is save it into. I use the root cursor in this case, but I'm actually going to recommend. I'm going to change this right now. Is to use the execution context, which has inside of it a map that you can store arbitrary stuff in. If okay, so yeah, so we want to we don't have a compute message if absent on the execution context. That's unfortunate. Maybe I could just add that right now while we're here, because I could say execution context is one of these guys, and we've got put message. And yeah, so I could just add a put if absent kind of thing here. Default. Let's see. I go to cursor. This is basically what I want. Yeah. So this has, so the cursor has one of these guys. Yeah, TT. Vault TT compute if absent. And I will just go and add this guy. Use the same method signature. This is where I meant to put that. And then, yeah, I suppose we'll just need to implement some of these methods. Yeah, so T message. So I could say get message. Well, I'll implement this later, but basically the idea was, yeah, store in the execution context the a map of the snippet to the parsed thing, and then retrieve that on an as-needed basis in order to not have to reparse the same snippet a lot. Now, you might very reasonably say that you might very reasonably say that the kind of challenge with this of like you're going to get the most mileage out of this cache if you don't have deviations from it, right? If every snippet you compile, like if every snippet is a cache hit, then you don't have to recompile things as often, but you most often want to parameterize this in some fashion. And so let me find an example of that in here. So in this case, in order to make this cache work as much as possible, like this recipe is trying to add this like dependencies, constraints, implementation, and inside of the implementation is a string literal containing a group artifact version coordinates. And we go look to where this is used here. I go ahead and compile it and store the result, or parse it and store the result in the snippet cache, and then I go and use a visitor afterwards to change the LST element this produces to have the values we want, to have the group artifact version constraints in there, because it's much faster to take an already built LST element and then just change a field on it here or there, rather than reparsing the same thing kind of from scratch. Okay, so that's kind of tips one. We'll call those together, tips 1 and 2 of parse. Parse random, parse text you need into LST elements with the parsers, and then save the result of those computations into the execution context, so that you won't have to do them frequently. So that's well and good. And oh yeah, and then when possible, cache things that are invariable, and then modify the resulting LST elements to have the specific values you want, if you're really concerned about performance and making your recipe run as fast as possible. In the case of this recipe, I sought to improve the performance here because one of our other recipes, find and fix vulnerable dependencies, uses this as an implementation detail and could invoke it many times. So slowness in this recipe could lead to that recipe timing out on large repositories, or repositories where it needed to make lots of changes. And, timing out is configurable, but the recipe was running in excess of 8 minutes, and so I went to add this caching to make that a lot faster. Okay, so that's tip number 1/2. For our next tip, I want to mention debugging JavaTemplate. I've already kind of alluded to JavaTemplate a little bit here. And this is a commonly used but not necessarily super well understood piece of recipe authoring tech. So I want to talk about what happens, or what you can do when JavaTemplate isn't working for you. And I don't have an example of a busted JavaTemplate invocation on hand, because if I did, I would just fix it so that it worked. Yeah, thanks. Thanks. I'm sure Tim appreciates it. LinkedIn user who is who's missing Tim, and yeah, I look forward to seeing. I guess this lovely person is going to attend at DevNexus. Cool. So yeah, Tim can look forward to that. Let's see. So So when you have a Java template, and if it wasn't doing what you wanted, and you were trying to figure out why, or you were trying to file a bug report to be like, hey, Java template is wrong, and please fix it. You can use this do before parse template method to see the snippet that that is about to be passed into the parser, in order to, in this case, produce this suppress warnings annotation. So I'm going to add this do before parse template callback and just put a breakpoint here, because I want to look at this in the debugger. Although of course you could just have it printed to the console. So if you print it to the console, remember to remove that before you are done with your recipe, so that you're not adding noise to people's logs with incomprehensible bits of Java source code. So let's run this and kind of see what we get there. There we go. Finally got the test running. Unable to construct Java 17 parser. Legal character. Oh, my local development environment is messed up in some way. Do I have open changes going on here? It's my fault for not checking. Do I have any local changes? Some, but nothing really relevant to that. Let's see if, after I pull in the latest changes, if this goes away. No. Well, now I might have a bug to go fix, and it looks like reflection utils, one of my lovely colleagues has maybe not accounted for Windows file paths in here. Well, that's something. When did this change? Okay, last week. I guess it's, or 2 week, almost 2 weeks ago. Something in here changed. So there's a bug for me to go fix. Find class path entries for doesn't work properly on Windows. Let's make a note of that. Let's see. I wonder if we have another. Where's another place that I could reproduce this that is more likely to be working? Let's see. Every logging framework's open. Something in here is going to use JavaTemplate, right? All right, so the system error to logging guy is going to use error to logging. Well, maybe let's skip logging frameworks. Let's go to one that I have more familiarity with off the top of my head. So let's get out testing frameworks. Let's find a JavaTemplate invocation in here. There we go. So simplify assert J assertion uses JavaTemplate. And so if I go to simplify assert J assertion test, I should be able to quite easily run some code that is going to get to demonstrating the thing I want to demonstrate. Okay, we've got a breakpoint in there. Let's run this. I guess this is my fault for trying to use things before I've updated my IDE and made sure that they were in good working order. You know, why am I using any of these? I should be using in rewrite recipe starter, which this surely has some JavaTemplate usage in it, right? Because we'd have to show off how to use JavaTemplate in this project. Okay, so no guava list, new array list. Is this guy going to run, or is everything in my development environment just hopelessly messed up at the moment? That would always be fun. All right, cool. At least my IDE has this project loaded and ready to go. So let's see. So no guava list, new array list. You use a JavaTemplate, and so I can finally maybe demonstrate this. Just whichever. I'll just put this on all of these guys so that whichever one we hit first, we can take a look at. All right, cool. So I've hit this value, and what I get back is a Java source file that looks like this. So let's kind of compare this to the source code here. So this is, we've hit this one, and so this is the snippet that is being compiled, this new array list invocation. And so the way JavaTemplate works can be kind of seen clearly, right? Like we take the snippet that is provided, and then we generate a Java source file around it, and then we pass that into the Java parser, and then we get back a full j.compilation unit LST, and then we traverse inside of it and fetch the LST element representing just this, just the requested snippet, and give that back to you. And so if any part of this process isn't working, if you're getting back some error from your JavaTemplate and you're like, why isn't this working? this do before parse template can show you the Java source file that has been constructed here, and then you can go paste it into a Scratch file like this and see if there's any like syntactical errors, right? Because this process is well, there could be bugs in any software, so there can be bugs in JavaTemplate, or some kind of mistake in the snippet you've provided. And whether it's a bug in JavaTemplate or a mistake in the snippet you've provided, coming in here and looking at this can help you to understand, and if you're filing a bug report with us, could help me to understand what's going on with your recipe. So obviously, in this case, this is a perfectly syntactically valid Java source file. But if we had messed, if the template invocation, or if the generation of a source file around your snippet was encountering some problem, you would be able to see that in here. Oh, hello, kitten. My assistant Astra is here to help me with this presentation. Although she thinks I should be focusing a lot more on petting the cat and less on talking about programming stuff. And she's gonna lend her tail to my face to assist in shifting my focus to what really matters in life, which is obviously cats. Okay, so let's see. So that's kind of tip number 2, debugging JavaTemplate. Let's go on to tip number 3, and this is kind of an architectural, like a design choice that you can make when you're trying to do more complex visitors. And the tip I have here is to create sub-visitors when you have something complex. So let's see if we have anything in here that already uses this technique. I think I'll just go ahead and revert the changes that I've made to this. So I don't need any of these changes in here anymore. Let's put everything back the way it was. So let's see, where might any of these places where this tip is relevant, because I'm kind of realizing that we don't have an example of this technique already in Rewrite Recipe Starter. And I'd like for, Rewrite Recipe Starter, if any of you are not already familiar with it, this is an example recipe module we have that if I go open this in GitHub, can get the URL for it and everything for everyone's perusal. Yeah, so Rewrite Recipe Starter, we have a bunch of example recipes in, and I have kind of selected these, or I and others have selected these to try and show off different aspects of the framework, so that you can have a piece of live documentation. When you clone this to get your recipe module started, the cat hair in my nose and mouth, that's exactly what I need during a live stream. So this is here to show off different aspects of the framework, and I'm kind of realizing that we don't have an example of creating a specialized sub-visitor in here already that I can use or show off, unless there's one in here. Probably not, though. Yeah. So what's a kind of good example of this? I know. Let's see. In rewrite testing frameworks. Yes, I can think of a good example in rewrite testing frameworks, and maybe that has already been loaded up for me. Then again, maybe not, if the IDE failed to load and build this project. Okay, so that's all up to date. So let's tell IntelliJ to build this guy, and hopefully everything will be in good working order after we do. Oh man, little cat hair stuck to my nose and eyes, and ugh. They're so cute, but even their cuteness can get at you sometimes. Let's see. So the recipe I'm looking for that I know has a good example of this technique is, Gradle use JUnit Jupyter. Yeah, here we go. So Gradle use JUnit Jupyter test. So this test class, or this recipe, maybe I'll split this so we've got the recipe on one side and the tests on the other side. This recipe exists to modify Gradle files to configure them to use the JUnit platform, right? To use JUnit 5. as this is used as part of the Java version upgrades and part of the Spring Boot upgrades. And at some point, when your projects move from using JUnit 4 to 5, if you build them with Gradle, you need your Gradle build files updated to declare use JUnit platform, which is the way that you tell a Gradle file to build with JUnit or to run tests with JUnit 5 rather than JUnit 4. And there are a whole bunch of different ways that this could be configured within a Gradle project. We want this recipe to handle all of them or as many of them as possible, right? And so, you might have the test DSL or be using this kind of shorthand to configure the test task. And if that already exists, we want to add the use JUnit platform there. And if there's a method that explicitly says use JUnit 4, well, we want to update that. Oops, don't want to actually change that test. Want to update that to say use JUnit platform. And if instead, because in Gradle, there's never just one way to do things when there could be 5 or 10 ways to do things. If instead the test task is configured this way, we want to take advantage of the existing invocation and reuse that. And if instead it is configured this way, we want to take advantage of it and use that, and so on and so forth. There's like 5 or 6 different ways that this could be already existing. And so if you can imagine writing one visitor that that accounts for all of these different possibilities, it is that one visitor would be quite complicated, right? It would be a difficult to maintain piece of software. And so kind of the first so the implementation of this guy, in order to make this problem tractable, of there being like 5 or 6 kinds of existing invocations that might need to be updated, and then finally add something wholly new if there's no existing option, the recipe is kind of structured accordingly. And so to begin with in this recipe, we have the usual defensive programming techniques of, avoid making changes to anything that isn't what we're interested in updating. And then we start off with, we use a sub visitor initially just to answer a question, essentially using a search recipe just to find, hey, is there already a JUnit platform invocation in this file somewhere? And so, this is a method that returns a Boolean, but the implementation of this creates a specialized sub visitor to traverse the file and to find if there's already any method with the name use JUnit platform in there. And if there is, it's presumed that the work of this recipe is done and no further changes need to be made. So, so this is inline, creating an anonymous class. In this case, might be used to seeing visitors have their type parameter filled in with execution context. This visitor doesn't need the execution context, but does, pass in an atomic Boolean in order to set that to true, and then ultimately just returns the value of that Boolean. Now, speaking of tips, you could use, if you override pre-visit and call stop after pre-visit, you will stop any further traversal into sub elements. So for performance reasons, if you're ever implementing a visitor where you have a very clearly defined endpoint, where like you found the thing you're looking for, you validated the validation that you want to make, and don't need to spend any further time or CPU cycles traversing trees and updating things that are already just don't need to waste any more time on traversal. You could call this stop after pre-visit method, and then that no more traversal into elements will happen. So that's kind of a freebie tip of a way to make your visitors faster whenever you have a visitor that can tell early on that it doesn't need to do any more visiting, that it's done. So, okay, so yeah, created a specialized sub visitor to go ask and answer the question, is this thing there? And then if it is, it stops early. And then if it isn't, there's several more specialized sub visitors to handle each of the different scenarios we saw in those test cases. So like the next thing this tries to do is update the existing use JUnit 4. So here is another specialized sub visitor which just handles this case. It just goes and looks for a method named useJUnit, and if it's there, it switches it to be this useJUnit platform method. And in this case, because this is a Gradle file, we might not have type attribution for everything, and so this mostly, yeah, Groovy comment even says that Groovy Gradle scripts being weakly typed means that we may miss changes, like this useJUnit method might not have type attribution on it, so we might not be able to use method matcher. And so since we can't use method matcher here, this more or less just looks for a method with to have the right name and number of arguments, and for the right number and kind of arguments. And if it is, well, that's supposed to be close enough. And then, just to be good citizens to any recipes that might run after, we make sure to update the type attribution on the method we return. So this one visitor handles essentially this one test case, and that keeps this one visitor very simple, right? And then if so that each of the idea being of decompose your recipe into small purpose-built visitors that are easy to understand. Because like one challenge with this recipe of like, if we were going to try to do this all in a single visitor, like how many times do we override visit method invocation in this file? Yeah, so there are, yeah, so in this file, there are 3 separate implementations of visit method invocation, each of them doing a separate thing. And you absolutely could. It would be possible to do all of this in one visitor that just had one monster visit method invocation that handled all of these different situations, but it would be unreadable, right? It would be a really difficult to maintain recipe because you had all these different usages of visit method invocation, all these different scenarios colliding in one implementation. And so decomposing this a really complex visitor into 3 much more simpler visitors helps this to be a significantly more maintainable recipe. So if you ever find yourself working on a recipe, and particularly I think the signal to look for is when you are in one override of a visit method trying to do 2 or more cover 2 or more wholly different scenarios, consider whether you could decompose that into multiple visitors, each of which had one kind of specific purpose. Cool. So that's kind of tip number 3 about doing sub visitors for these things. I think for tip number 4, I think what we will do is how to do HTTP communication in a recipe, right? There are already a bunch of recipes out there that use that will do like dependency resolution, like looking up dependencies that are available from artifact repositories. And so if you're, upgrading a dependency or something, you can use some of those utilities. But like a recipe is a Java program. So if you wanted to reach out to some external service or like call some API, then you can do that, right? Like you could put anything in one of these that you put in any other Java program, but there's a specific way to do HTTP communication within a recipe so that all of the proxying will work. And it all kind of starts from our HTTP sender implementation. And there's a couple implementations of this in here, but let's find the usages of this guy. Let's find an example of this used in a recipe. So there's one in remote archive. There's one in, yeah, this is sometimes used as a test utility as well. Let's see, we've got some in rewrite core, distribution infos. What is going to be? Okay, so update Gradle wrapper has some of this stuff. But basically, if you want to do HTTP communication in a recipe, this is how you should do it, right? Like you could, if you just like, new up your favorite, Apache or Spring or whatever, or OK HTTP library into your recipe, that might work. But if you go to run that recipe in the SASS or in the CLI or just like in some other context, it might need that HTTP communication to work, might need to be proxied through something. And the way that we handle like proxying an open rewrite is that we would pass in an execution context to the recipe run that has an appropriate network configuration to work in whatever environment that recipe is running in. So the appropriate way to get something that can do HTTP communication within a recipe is to use this HTTP sender execution context view to get a type safe accessor around the execution context. And then you call this get HTTP sender method off that. And that gives you back this HTTP sender that you can use to go and issue requests to arbitrary endpoints. And so this is the tip that in true, clickbait fashion, we announced that this could shock you. And I don't have a live demo of this because I'm a hack. But if the way this could shock you, I suppose, is if you had some electrical device that was open to network communication, say a little small desk Tesla coil or a car battery or something, you could have a recipe send an HTTP request to you that would act, to that device that would activate it. Now, I don't generally recommend you use recipes to control Internet of Things devices in your homes, but who knows? Maybe if people did, and their IoT devices would be kept up to date a bit more often. Thank you for laughing, Jasmine. That's very generous of you to laugh along to my incredibly lame example of how this item is shocking. It requires a little bit of imagination, a little bit of mental participation on the part of the viewer to make number 4 shocking. So anyway, if you wanted to do network communication in a recipe and you want it to be proxied correctly, work on the modern SaaS or elsewhere, be sure to get your implementation from here. And if we go, I guess just to talk a little bit more about HTTP sender, there's an interface here that we have implementations for OK HTTP, or I guess this is one in. I guess this is just in test code for using the OK HTTP library. But there's a HTTP URL connection sender, which just uses Java built-in stuff to do basic HTTP communication. But if you had some other library that you preferred to use, it's quite easy to implement HTTP sender. You just have to implement this one method, this one send method, and then all the other default implementations will use that. So you just need to implement this one send method, and you could have whatever network communication library you prefer be in use within your recipes. And then, if you were running recipes in some custom fashion, could further supply that into the execution context. Okay, so let's see. That's tip number 4. So let's just do one more tip, number 5. And so this is about how you delegate to scanning recipes. Regular recipe authors will already be familiar with what a scanning recipe is. And just to bring everyone else kind of up to speed on a scanning recipe, here is the example append to release notes that is contained within the rewrite recipe starter repository. And so this scanning recipe, a scanning recipe is one that gets to participate in the scanning phase of recipe execution. And a regular recipe that is not a scanning recipe doesn't get to do this. It only gets to participate in the editing phase of recipes. But a scanning recipe gets to override this get scanner method, which gets to look at every file in the LST, every file in the repository before any changes are made, and gets to decide whether or not it wants to save any information. Can't make edits during the scanning phase. Can only save information off into an in-memory data structure that you define, that by convention we tend to call the accumulator. And then and that accumulator is passed through, right? So that the get visitor method, it expects to have this available. Now, if you're used to composing recipes together in other recipes, you might be used to doing something like, I don't know, like we go plain text recipe here, like, if we wanted to say, new find, like if we wanted to use this find recipe to search for, Sam, I'll look for, false, 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 false. One more false. Oh, no, wait. This is null. All right, cool. So like with the non-scanning recipe, if I wanted to use it, within this context, I could just do something like this, right? I could say, I could new up the recipe, I could call get visitor, and I could then just immediately apply that visitor and get the result back. And this works great. Now the problem is that in a scanning recipe, get visitor is insufficient, right? Like I could do this with find, because find is a regular recipe. It's not a scanning recipe. But a scanning recipe, for it to work properly, you got to be passing in an accumulator, which has been populated with data from the scanning phase of that recipe. So if you want to call a scanning recipe from another recipe, you have to populate its scanner. And so I have an example. There's an example of this in rewrite Java dependencies in like add dependency, for example. So the rewrite Java dependencies add dependencies uh, calls out to the Gradle and the Maven add dependency recipes. So you could have one recipe that, regardless of whether it's running on Maven or Gradle, does both, right? Saves you the trouble of typing things out. And each of these guys are themselves scanning recipes. So in order to use them in the visitor here, we can't just call, where is it? Oh yeah, get visitor right here. So we can't just call the Gradle add dependency recipe get visit or get visitor. We have to pass in an accumulator commensurate to the task. And so if you want to compose scanning recipes together, one, it has to be in a scanning recipe because you don't get to participate in the scanning phase otherwise. But the short version is you just do this, right? If you're going to use other scanning recipes in your scanning recipe, you've got to have a scanner that provides the accumulator. So like this recipe's accumulator just has the accumulators from those other recipes, which is maybe also a tip that you should make your accumulator class public, because like you don't necessarily have to, but if you don't, then it becomes a lot harder for other scanning recipes to compose your scanning recipe together. And it might be nice if the framework had more support for this, like made it easier to compose scanning recipes together. But I haven't thought of an idea for how we could change the API to actually do that. So if you have a good idea for how to make this composition work better, send me a message. Let me know. But in the meantime, if you want to use other scanning recipes, the short version is you create an accumulator that is that contains the accumulators for the other recipes that you want to scan and or that you want to use, and then in the scanning phase for your recipe, you call that other recipe's get scanner, pass in the accumulator, do the visiting, and so this leads to the Gradle recipe gets its accumulator populated, and the Maven recipe gets its accumulator populated. And then later on, when we want to use them, we have those accumulators available, right? We have the accumulators available. We can call the scanning recipe get visitor, which accepts the accumulator as an argument, and this allows us to use those, right? Like if I take this out, well, unfortunately, there's no compilation error here or anything because this method still exists. It's just that it won't work correctly without this. So if I call, like if I go to, do we have any tests for this guy? No, I just composed. Oh, we do have some tests. So if I change this and I just call get visitor and I go run these tests, I think we're going to see is that, that no updates happen in particular. So I guess the thing to look out for here, the way to know that this is the tip you need, the way to know that this is going wrong is unfortunately something you can only kind of figure out at runtime on your recipe because there's no compilation error. But it is like if you are calling recipe.getVisitor on something, like this isn't changing anything, but it should be. Like I'm applying this to the kind of thing this recipe is supposed to change. Why isn't it changing what it's supposed to? Well, double check real quick if the recipe you are trying to call is itself a scanning recipe. And if it is, realize you need to call the version the overload of get visitor that accepts an accumulator and pass in a populated accumulator. Otherwise, your recipe ain't gonna work. So I think that's our 5 5 tips for the week. Hopefully that all of you recipe out there found these to be useful and informative. And yeah, I think that is a good stopping point for now. So thank you all for joining me. Next week, Tim will be back, and I think we may have some other exciting guests on as well. So look forward to next week's episode. And in the meantime, be sure to go register for Code Remix Summit in Miami, Florida, coming in May. It's going to be a good time. I hope to see all of you there. And until next week, have a good one. Keep on writing recipes and refactoring and modernizing your code. Bye now.